Alright, so today we're talking about lesson 12-5, which is on graphing circles. Depending on what book you're using, it might say circles in the coordinate plane, but that's just a fancy way of saying that you are graphing circles. So here we go. The standard equation of a circle, so you're going to need to memorize this. The standard equation of a circle is x minus h squared plus y minus k squared equals r squared, where the center of the circle is at the coordinate hk, so that's where the h and the k come from, the center of your circle, and the radius is r, so that's what this r represents. Okay, now I'm not just going to give you that and say let's do some problems. I want to show you why that exists. It's really just a glorified distance formula, so let's look at why that exists. So if I have a circle here, excuse me, and the center is at HK, right? So as you see here, the center is at HK, right? And it has a radius R. Okay, so those things are true here. If I wanted to know, though, if I wanted to solve for R, I would have to use the distance between these 2 points here, right? The distance between those points. So to do that, I would use the distance formula, which says that r equals the square root of, well, the difference between my x values squared, which are, we can just write as x minus h squared, plus the difference of my y values squared, y minus k squared, which already kind of looks like it, except our actual formula has r squared. This one just has r, so we should square both sides, right? So we'd end up with r squared equals, when you square a radical, it basically cancels it out, right? Because we just squared both sides, and you end up with x minus h squared plus y minus k squared. Right, so again, this up here, this part here is just the distance formula, so we just use that to come up with this. Again, this is called the standard equation of a circle. So that equation right there is called the standard equation of a circle. Now, how do we use that? Why is that important? So they may ask you to write the equation of a circle centered at 3, -4, or with center at 3, -4, and a radius of 6. So again, I'm going to write the general equation, which is x minus h squared plus y minus k squared equals r squared. Well, again, the center is h comma k, right? So in this case, h is the x value of my center, which is 3, right? H is 3, and the k is the y value of my center, which is 4. So -4. K is -4. So I'm going to plug those in. So I get x minus 3 squared plus y minus -4, which really just becomes the opposite, right? So it's y plus 4, which then equals, well, what's the radius again? It says that my radius is 6, which means I'm going to put 6 squared here. So here's the key thing. If you notice, my center is at -3, 4. Wow, I'm all mixed up. My center is at 3, -4, and in my equation I see -3, +4. So it was 3 as my center, I see -3 with the x. It was -4 in my center, I see +4 with the y. So it's just the opposite, right? So if it helps, just make sure you know that it's just the opposite of the coordinate values. Okay, we're not done, however, because we still have to square the 6. So the final answer would be x minus 3 squared plus y plus 4 squared equals 36. And that would be your answer, right? That's it right there. And again, because that's in standard form. Now, you could have another question. Write the standard equation of the circle -1, 2 that passes through the point -2, 3. So I'm not going to graph this necessarily for you. It just means it has this center, and by passing through the point, it means that the circle itself is going to go right through that point. Okay, so here's the point. That means it passes through this point. This circle also passes through that point, and that point, and that point. It's passing through all of these points on the outside. Okay, so that's kind of the visual that they want you to get when it says passing through that point. You don't have to graph it to do this problem, though. What we want is we want to plug these in. It gives you the center, right, the standard equation of the circle. This here, sorry, this word problem was written wrong. This is the center, and it passes through the point 2, -3. Okay, so again, the center is HK. Well, this point that they give you, because they don't give you the radius, right? The radius, we don't know what it is. So we need to find that. Well, this point that they give you, we're going to substitute for x and y, because if you remember from the original little proof thing that we had here, the point that it passes through is x comma y. Okay, so if it passes through that point, we're going to replace it with x, y. So we end up with, again, I'm going to write it just so you're used to seeing it, x minus h squared plus y minus k squared equals r squared. We know that x is 2, h is -1, so I end up with plus 1 there, plus y is -3 minus k, well, k is 2, equals r squared. 2 plus 1 is 3, so it's 3 squared plus -5 squared equals r squared. So we get 9 plus 25 equals r squared. Therefore, 34 equals r squared. Now, a lot of people are going to be tempted to then take the square root, say r equals rad 34, and then if it's another number, they would try to simplify the radical. There's no need to do that because the equation calls for what? It calls for r squared in the equation. It doesn't ask for r. So we already have r squared, which means now we can write the standard equation. So I'm going to erase this at the bottom to give us some room. We know that r squared is 34, which means now I'm going to rewrite this as x plus 1 squared plus y minus 2 squared equals r squared again was 34. And you're done. Okay, so you don't need to simplify your radical there to find r unless it's specifically asking you to do so. Now they could ask you, oh, you know, a circle has a center, 1, -2, and it goes to the point 2, -3. Find the radius. Then you would take the square root and get rad 34. They could say find the diameter. Then you would double that and get 2 rad 34. They could say find the circumference, meaning you'd plug that into 2 pi r. They could say find the area, meaning you plug that into pi r squared, right? So there's a lot of things they could ask you from there, so you really have to be careful when you're reading these questions, okay? All right, let's do an example. Again, if this one's different, they give you the equation, and they want you to graph it. So again, let's analyze what the equation says. X minus h squared plus y minus k squared equals r squared. So this value here, x minus h, right, turned into x minus 2, which means that h is 2. Y minus k squared is just y squared, which means it's really y minus 0 squared, right? So when there's nothing added or subtracted to it, it really just means that the value for your center there is just 0. And then r squared is 9, therefore the radius is 3. So my center, again, is h comma k, which in this case is going to be 2 comma 0, with a radius of 3. So what I'm going to do is I'm going to go to 2, 0, so to the right 2, up and down 0, so the right, that's my center there, and my radius is 3. Here's what I think the best strategy is when graphing this. Some students are going to want to be like, oh, I'm going to go up here 3. Well, that's not actually 3, right? That's not a distance of 3. What you should do is go up 3, so 1, 2, 3, like so. You're going to go up to that point, and you're going to plot that point. You should then go down 3, so down 1, 2, 3, you're going to plot that point. To the right 3, 1, 2, 3, you're going to plot that point. And to the left 3, 1, 2, 3, plot that point. The reason I say that is because then it's at least somewhat easier to connect those without making too funky of a shape, right? Obviously, mine is not drawn to scale. It's not fantastic. It should look something like that if you have a circle app to use on your tests, for example. Anyway, so that's kind of how we piece it together. Start with the center, right? You analyze the equation, you find the center, you find what the radius is, and you just count up, down, left, and right in that direction. Okay? If you are doing that, if the radius is not a nice number, like let's say you get a radius of like rad 27, right? It's not a nice number. Well, I would say, again, this is hypothetical, right? This is not part of this problem. Let's say r is rad 27. Well, that's a little bit more than 5, right? It's approximately 5. It's a little bit more. So I'm going to put a little bit bigger than 5. Well, then you would count 5 and then just a little bit further, right? So it's an estimate at that point. You're not going to be exact there. But that's kind of the strategy when doing that. All right, let's move on. So this one again, it says write the equation when you're given the graph. So again, the general equation, I keep writing this over and over again. It's important to know. X minus h squared plus y minus k squared equals r squared. I need to know h, k, and r in order to write the equation. So I'm going to look at my graph. The center is here. The center is the coordinate, what? Well, it's left 3, so negative 3, up 1, positive 1. So I just figured out that h is negative 3 and k is positive 1 because that has to do with my center. Now I just have to count the radius. 1, 2, 3, 4. R is 4. And now I just plug stuff in. So I get x plus 3. Again, it's the opposite of the value we had. It was negative 3 here. It's positive 3 here, right? Plus y minus 1 squared equals 4 squared, which you would write as x plus 3 squared plus y minus 1 squared equals 16. And that would be your answer. All right, one more problem, and then you are done for the day. It says a circle has a diameter AB, and it says that the point A is at 3, 0, and the point B is at 7, 6. So it's asking you to write, they want to write the equation in standard form. So we have x minus h squared plus y minus k squared equals r squared. Well, do we have any of these? We don't, right? We don't have any of these. We don't have h, k, or r. Well, here's the strategy. The center is the midpoint of your diameter. So what's right in between 3 and 7, right? So the average of 3 and 7, 3 plus 7 over 2, and then 0 plus 6 over 2 will give you 10 over 2, which is 5, comma, 6 over 2, which is 3. So I know it's going to be x minus 5 squared plus y minus 3 squared equals, now I just need to know my radius. I need to know my radius. Well, there's two strategies. Find the length of your diameter using the distance formula, or plug in one of these points for x and y now that you have your center, and it will help you solve for the radius itself. Okay? It'll help you solve for the radius itself. So I'm going to do that. I'm going to say this equals r squared. I'm going to plug in 3, 0. I think it'll be easier to plug in. So 3 minus 5 squared plus 0 minus 3 squared equals r squared. So I get, this is negative 2 squared plus negative 3 squared equals r squared. That's 4 plus 9 equals r squared. Therefore, r squared equals 13, which means my equation, that 13 is just going to go here, and then I will be done, right? It should be that simple from there. The 13 is going to go up there, which means I should have x minus 5 squared plus y minus 3 squared equals 13, and that is your final answer. Okay, so there's a lot of different roundabout ways. I did not include any of the problems like find the area of the circle or anything like that, but you should be able to do it. Once you find the radius, which in this case is rad 13, right? Once you find the radius, you should be able to plug that in and go from there. Anyway, that's it for today. Hope you learned something new. Have a good day.